So question 4, in the diagram, BCD is a circle with center A. Angle BCD is equal to 2s plus 40 degrees. BAD is equal to 5s minus 35. Angle BED is equal to 2s plus 10. And angle ADC is equal to 40 degrees. Find 1, the values of x and y. And 2, angle ABC. So here we have a circle with sides BCDE. Now BCDE forms a quadrilateral whose vertices are on the circumference of this circle. So that makes it a cyclic quadrilateral. ABCD is not a cyclic quadrilateral because this point here is not at the circumference. Okay, so but this is a cyclic quadrilateral. So let me explain some terms here. So if I have a circle and I have a quadrilateral inserted in such a way that all the points of the quadrilateral touches the circumference, and this is a cyclic quadrilateral. Now let's assume that I have this and I draw this through this, and this is the center O of the circle. So if this point is A and this point is B, then A plus B is equal to 180 degrees. And if this is C and this is D, also C plus D is equal to 180, because the sum of the opposite angles of a cyclic quadrilateral is always equal to 180. Now again, if this is X and this is Y, angle X will be equal to 2 times B, and angle Y will be equal to 2 times A. So the angle at the center is always twice the angle at the circumference. So you see this also at the center is twice this. So let's go back to the question. Now for this, so you can clearly see that this angle here, C plus E, this angle here is equal to 180. So we have 2x plus 40 degrees plus 40 plus 2y plus 10 degrees is equal to 180 degrees. So let's take the reason. Opposite angles of a cyclic quadrilateral. And what's the name of the quadrilateral? Of quadrilateral BCDE. BCDE. So for this, I'm going to have 2x plus 40 plus 2y plus 10 equals 180 degrees. So we have 2x plus 2y plus 40 plus 10 is 50 degrees is equal to 180. So 2x plus 2y equals 180 degrees minus 50 degrees. Okay, so from here we can see that 2x plus 2y is equal to 130 degrees. Okay, we can simplify this to make our work easier. So I'm going to have divide both sides by 2. So I have x plus y is equal to 130 divided by 2. That's 65. So we can call this equation 1. Okay, next, let's go back to this. Now we have made use of this angle. So from here, you can see that this angle will be equal to twice this angle. That's 5x minus 35. 5x minus 35 is equal to 2 times this angle here. That's 2y plus 10. So let's take the reason. Angle at the center is equal to 2 times angles at the circumference. Okay, so let's work this. So I'm going to have 5x minus 35 equal to 4y plus 20. 2 times 2y, 4. 2 times 10, that's 20. So let's simplify it. I'm going to have 5x. I'll take this will have minus 4y is equal to 20. When I move this I'm going to have plus 35. So I have 5x minus 4y is equal to 20 plus 35. That's 55, equation 2. So we have two equations here. Now we can use substitution or elimination method, but it's going to be easier to use substitution method because the coefficient of these are just one. So from equation 1, I'm going to make y this one. So I'm going to have y equals 65 minus x. So I'll call this equation 3. Then I'll substitute equation 3 into equation 2. So if I substitute that, I'm going to have 5x minus 4 into, so wherever I see y, I'm going to put 65 minus x is equal to 55. So that's what I'm going to have 5x minus 4 times 65. That's equal to 260. Minus times minus is plus. 4 times s, 4x is equal to 55. Okay, so collect items, add this and this to that gives us 9x equals 55. And take this way plus 260. So I have 9x is equals to 55 plus 260. That's 315. So now we're going to divide both sides by 9. So x is equal to 350 divided by 9. That's equal to 35 degrees. So x is 35 degrees. So we can go back and substitute s here to get the value of y. So y will be equal to 65 minus x. That's 35 degrees. That will be equal to 30 degrees. So therefore, x is equals to 35 degrees and y is equal to 30 degrees. Now let's go back to the other part of the question. We're asked to find the values of, I'll just work that this way, the values of angle A, B, C. This angle here, we have to look for this very angle here. So we can get the values of this angle, this, and we know that this is 40. So first of all, 5x minus 35 will be equals to 5 times 35 minus 35, because the value we obtained for x, the value we obtained for x was 35 degrees. So that will be equal to 5 times 35 minus 35. That's equal to 140. So this angle here is, this angle here is equal to 140 degrees. Then we'll have to look for this again. So we have 2x plus 40 will be equal to 2 times 35 plus 40. So that will be 72 times 35 plus 40. That will be 110 degrees. So this angle here is 110 degrees. So now this is a quadrilateral ABCD. So in quadrilateral ABCD, the sum of this angle, this, and this will be equal to 360 degrees. So BAC or ABC plus this angle here, which is 110 degrees, plus this angle here, which is 40 degrees, plus this angle here, which is 140 degrees, is equals to 360 degrees. We still have to state the reason. Sum of interior angles of a quadrilateral. Okay, so we can work this out together. So ABC, that's angle ABC, is equals to 110 plus 40 plus 140. So that will be ABC plus 290. So the sum of this and this is equal to 290. It's equal to 360 degrees. So angle ABC is equal to 360 degrees minus 290. That's equal to 70 degrees.